Now we are going to see different types of nonlinearities observed in the structures. First is a material nonlinearity. For example, a metal forging. Second is geometric nonlinearity. For example, hammock ropes. And third is a contact nonlinearity. For example, meshing gear teeth. Now we are going to see what is a material nonlinearity. Stress and strain in many materials is not linearly proportional to each other. For example, a stress versus strain curve of a cast iron is shown in the picture. The stress-strain relation has a nonlinear term that makes stress proportional to a square of the strain. Nonlinear stress-strain relationship can be a characteristic of certain materials, like rubbers or polymers. Even materials with linear stress-strain relationship, like steel, demonstrate a nonlinear relationship between stress and strain, near and after the yield stress of the material. Therefore, metal forging, in which materials are stressed beyond the yield stress of the material, is a good example of a material nonlinearity. Now let us understand what is a geometric nonlinearity. In the geometric nonlinearity, the deformations in the structure are so large that the direction of loading, or equations governing the deformations in the structure, change with the deformation. For example, see an unloaded hammock shown in the picture. When it is loaded with the weight of a human being, the deformations are very large. Initially, the hammock fibers bend with the load. As the deformations further increase, many fibers experience axial rather than a bending load. As the physics changes from bending to stretching, linear load deformation loss at the beginning of the deformation are no longer valid. Third type of nonlinearity is a contact nonlinearity. Whenever two or more bodies in the structure form or lose contact with each other, the condition is known as a contact nonlinearity. In the contact nonlinearity, boundary conditions, or the stiffness of the structure, changes as the bodies form or lose the contact. For example, the cycle wheel rim and brake pad is shown in the video below. As the brake pad comes in contact with the wheel rim, the rotational motion of the wheel is restrained by the frictional force at the brake interface. The wheel is again free to rotate, as the contact is lost between the wheel rim and the brake pad.